That ticking is a dead star, a real radio signal from a stellar corpse converted into sound, and it has kept better time than some clocks on Earth. Last episode, you heard a black hole. This time it's the thing that's arguably weirder, because a black hole hides its madness behind a horizon. A neutron star does it all in the open. 10 facts, all sound fake, all real, peer-reviewed, and sourced on screen. Number 5 is probably on your body right now, and number 10 happened this year. Fact 1. Take a sugar cube. Fill it with neutron star material and it would weigh about as much as Mount Everest. Hundreds of millions of tons in something that fits between your fingers. A full teaspoon, roughly 1 billion tons. That's more than every human being alive, combined in a spoon. Here's why. When a giant star dies, its core collapses so violently that protons and electrons get crushed into each other, becoming neutrons. What's left is a ball with more mass than our sun, squeezed into a sphere about 20 kilometers wide. The sun, compressed to the size of a city. It is the densest thing in the universe that we can still actually see. One step denser, and it becomes a black hole and disappears. And that crushing does something very strange to the surface. Fact 2. Neutron stars are the smoothest objects known to science. Their gravity is so ferocious, billions of times stronger than Earth's, that nothing can pile up. In 2021, physicists at Southampton modeled the tallest possible mountains a neutron star's crust could support. The answer: fractions of a millimeter. An entire star heavier than the sun, whose Mount Everest is smaller than a grain of sand. It is the closest thing to a mathematically perfect sphere the universe has ever built. And that gravity has consequences. Drop something from 1 meter above the surface and it slams down at over 1,000 kilometers per second. But smooth and still are not the same thing, because these corpses spin. Fact 3. There's a dead star spinning 716 times every second. It's called PSRJ 1748, inside a star cluster 18,000 light-years away. Not 716 times a minute, per second. A ball of star stuff heavier than the sun, rotating faster than a kitchen blender. At its equator, the surface is moving at roughly 1/4 of the speed of light. And here's the part I love. When the first spinning neutron star was discovered in 1967, the signal was so unnaturally precise that astronomers half-jokingly labeled it LGM1, Little Green Men 1. For a moment, the most rational explanation on the table was aliens. It wasn't aliens. It was something almost harder to believe, a lighthouse made of a dead sun. So they're fast. Now let's talk about what they're made of. Fact 4. The strongest known material in the universe is called nuclear pasta. That's its real, published scientific name. About 1 kilometer under a neutron star's crust, pressure squeezes atomic nuclei into shapes physicists couldn't help naming like an Italian menu. Gnocchi, spaghetti, lasagna. In 2018, researchers ran 2 million processor hours of simulations to digitally break this stuff and measure its strength. The result: nuclear pasta is about 10 billion times stronger than steel. If you had a girder of it here on Earth, nothing in human industry, no press, no explosive, no diamond blade, could even scratch it. It only exists because a dead star's gravity holds the recipe together. Okay, time for the fact I promised is probably on your body right now. 10 honest seconds. This channel does one thing: facts that sound fake, fully sourced. Black holes were episode 2, this is 3. If your brain likes this, subscribing takes 2 seconds. Now, check your hands. Fact 5. The gold on your finger was very likely forged in a collision between 2 neutron stars. Normal stars can fuse elements up the periodic table, but they stall around iron. Gold, platinum, uranium. Stars can't make them in their everyday lives. For decades, where does gold come from was a genuinely open question in physics. Then, in August 2017, detectors caught two neutron stars smashing together, 130 million light-years away. Telescopes watched the explosion glow with the signature of freshly minted heavy elements. That one collision created heavy elements estimated at thousands of times the mass of the Earth, including somewhere around an Earth's worth, possibly several, of gold and platinum. So your ring, your necklace, the gold in your phone, that metal likely rained out of a catastrophe between two dead stars, billions of years before the sun existed. You are wearing shrapnel from the most violent event in the galaxy, casually, and if that's what their deaths make, wait until you meet their jewelry. Fact 6. Orbiting a pulsar 4,000 light-years away, there's a planet that is very likely a giant diamond. It started as a star. Its companion pulsar stripped it down to its naked crystalline core, and what's left is a Jupiter-mass world of compressed carbon about 20 times denser than Jupiter. The published conclusion: probably crystalline carbon, a planet-sized diamond. Its entire orbit is so tight it would fit inside our sun. Its year lasts about 2 hours, and a bonus twist most people never hear. The first planets ever discovered outside our solar system, before any planet around a normal star, were found in 1992, orbiting a pulsar. The first alien worlds we ever confirmed circle a corpse, but some neutron stars don't collect jewelry. Some are just weapons. Fact 7. Some neutron stars could kill you from 1,000 kilometers away, using neither heat nor gravity nor radiation. Using magnetism, they're called magnetars. Neutron stars with magnetic fields trillions of times stronger than Earth's. Get within about 1,000 kilometers and the field itself deforms your atoms, stretching their electron clouds into thin rods until chemistry, including the chemistry that runs your body, simply stops working. You wouldn't burn or get crushed. Your molecules would just stop being possible. From roughly half the distance to the moon, one could wipe every credit card on Earth. And this isn't theoretical. In December 2004, a magnetar flare from the other side of the galaxy, 50,000 light-years away, washed over our planet and measurably disturbed Earth's upper atmosphere. Satellites felt a dead star sneeze from across the Milky Way. Quick pulse check. Which fact has broken you so far? Number in the comments. I read all of them. Fact 8. The heaviest neutron star ever measured got that way by eating its own companion. PSRJ 0952 is what astronomers officially call a black widow pulsar. Yes, that's the real classification. For billions of years, it has been blasting its partner star with radiation and swallowing the vapor, spinning itself up to 707 rotations per second in the process. It now weighs in at about 2.35 times the mass of the Sun, the largest well-measured neutron star mass on record, and physicists believe that's near the ceiling. Pack on more, and a neutron star can no longer hold itself up. One meal too many, and it collapses into a black hole, vanishing behind an event horizon mid-bite. We may literally be watching an object eat itself out of existence, which raises the question of what's holding it up in the first place. The answer breaks the periodic table. Fact 9. A neutron star isn't really made of atoms at all. Deep down, it's closest to one single atomic nucleus, the size of a city. Everything you've ever touched is atoms, a nucleus, electrons, and mostly empty space. A neutron star is what happens when gravity deletes the empty space. The interior fuses into one continuous ocean of nuclear matter. No elements, no chemistry, no periodic table. Chemistry needs atoms, and atoms can't survive there. And the very center, we genuinely don't know. The pressure is beyond anything physics can test on Earth. Matter may dissolve into free quarks, a state the universe hasn't hosted at scale since the instance after the Big Bang. Every neutron star is a locked laboratory holding the answer to what is matter really. And the door is a surface gravity billions of times ours. One more. The one that happened this year. The one I flagged at the start. Fact 10. In March 2026, astronomers announced they had for the first time watched a magnetar being born. A distant, ultra-bright supernova refused to fade smoothly. Its light pulsed, 4 bumps each arriving faster than the last, a pattern astronomers called a chirp. If you watched episode 2, you know that word. It's the same signature LIGO hears when black holes collide. The explanation: inside the explosion sat a newborn neutron star, already spinning about 240 times per second. Its wobbling debris disk blocking and unblocking the light like a hand over a lamp. With a magnetic field roughly 300 trillion times Earth's, sit with the timeline. A star that lived for millions of years died, and within days its corpse was a city-sized sphere, spinning hundreds of times a second, screaming its existence into its own explosion. We didn't find a magnetar. We watched the universe make one this year. You made it, so here's the bonus. Fact 11. Our home address is written in neutron stars. The Voyager probes carry the golden record, humanity's message to whoever finds it. On its cover is a starburst map. 14 of its lines each point to a pulsar, labeled with its exact spin rate. The 15th runs to the center of the galaxy. Pulsars tick so reliably that any civilization could use them to triangulate their way back to us. When we introduced ourselves to the galaxy, we didn't use stars. Stars are ordinary. We signed our location using dead ones, because nothing else in the universe keeps time like a corpse that refuses to stop spinning. That's episode 3 of Sounds Fake but 100% real. The black hole episode is on your screen now. Fact 10 in their pairs disturbingly well with what you just learned. Episode 4 is already brewing. It sounds the fakest yet. Subscribe so it finds you.